Ready for it? So can you concentrate for this bit?
Yeah.
If we draw it up, if I make it reasonable, I do talk to you about the Mr. Bean method, and that was 100. We talk about nose to tail. If I put this nose on the tail of that one, so there it is there, Mr. Bean method goes across there somewhere. By the way, if that was 100, that's looking too big, probably about there somewhere. If that was 100, still a bit too big, isn't it? Where's all my angles? I can put a cross in if I want to. I'm going to go that angle's 25 degrees. Which one is that angle is?
65.
You guys are not that used to adding up to 90, are you? 65. Now, by the way, just some common sense, where's it going to head? Look up for this. It's got to go up there somewhere. Where is the resultant, which is a representation of where it's going to go on the diagram? Say it for me. From there to there. So some people will draw it up as a dotted line as a resultant. Oh, drawing on the whiteboard is shocking. And they want to know how strong it is, and they want to know what direction it's going. So what's the topic? Cosine rule, sine rule. Thank you. Cole, you're going to say something, Cole?
I was going to say, did you work it out using cosine rule for the magnitude?
Yeah. Now, Cole, I'm going to say again, some people need to draw it separate and get away from all the clutter. And they'll go, that's 90, so you've got 155 for getting that. And there's a 80, and there's 100, and my goodness, that's year 10 level, simple cosine rule. What's the thing? We talk about the resultant. And we talk about that one's nose to that one's tail. I always think of elephants. I remember watching those nature programs, and the elephants are walking along, and this one's got his nose at that one's tail. And they walk in a line. You ever seen them do it? Well, the better one here in WA is those little caterpillars. You haven't seen them. Some of you are walking in the bush, you get like 100 really fluffy caterpillars. Don't touch them, they're very irritating. And they walk along, follow each other. So what a lot of kids, especially boys, do, flick them apart so they can't follow each other. So it's nose and tail. Now, the rest of the calculation. Remember what's the next one? Well, don't worry about the calculations from now. So I could do it two ways. I could get that out of the way. I could put that one over there. Yeah. Or I could put this one over there. So both going to give me the same answer. So you've got two ways you can think about it depending on what your brain does. So the resultant's almost north. It's a bit annoying because that gets horrible to draw the calculations. Well, anyway, who cares? There's the resultant up here somewhere. Now this is annoying if I make that a dotted line. So this is where I tend to just go. Crosses. Cross there, and then I put a dotted line. Now that dotted line, I'm glad I made that. It's a bit yucky, okay? And there's your resultant. Angles. This is where I think some of you have trouble with the angles. Do I need to draw it separate? Probably. If you put this one over here. Now if you don't need to watch, just do the questions, okay? So I've got that one to 250. Oh, terrible diagram. And I put a cross there. And I go, well, wait a minute, what happens? Here's what people's brain does wrong. There's a cross there. So there's the cross there. So I've now got this one coming up here. So if that was 250 newtons, this one's 200 newtons. What are the angles? We know that this one here, that one there is 40. So what does that make that one? 50. Now do this bit of the angle here. Z shape. This was 30. So what's to make that one? 60. You okay? You're not just saying yes when you should say no. I'm reading your eyes. So if that's a 60 there, the Z shape means it's a. Are you guys saying that you would have been good if you had this before the methods test? You didn't get it off, yes, did you? So, do you want to draw a separate diagram? Yeah, I would. There's 250, there's 110, there's 200. What am I going to find? There's the easy one. Where's the awkward one? That one there. So give it a go. If you're finished, you can just get on with the textbook, okay? But I'm going to go through that if anyone wants me to. Anyone want me to do it? Your look on your face is going diagram. So, how quickly can I do this? It's a cosine rule because there's things on the three sides, so I just go x squared equals 80 squared. Do you see the form in your head now? Do you have to think through the letters? 2 times 80 times 100 times the cos of 155. I pick up my class pad, just type cut shift equals. Yeah? You okay? Type it in, does that give you the answer? Trap is degrees, make sure you calculate 7 degrees. So can you do that for me, get me that answer? Yes, sir.
Give the resolution, or the magnitude, sorry, and point below. What unit would you use?
If it was in newtons to start with.
So you just put it in
Yeah,
units?
yeah.
Okay.
So you guys have done newtons before, haven't you?
Yeah.
So the resultant would be whatever in newtons and, do we need to give degrees and newtons?
Yes.
Okay.
Remember, so a vector has to have
Direction.
magnitude. Got it. And then, see, this didn't say north, south, east or west. So it's not about bearings. Could make it about bearings, but it's not. So you're going to make sure your description of the answer is very clear.
So you'd find theta as well?
Yeah.
So it would be x newtons,
Yeah.
theta degrees.
Yeah. And what would you say for your 30 degrees? There's different ways of doing it. Let's finish this one off a second. Have you got that for me?
Yeah, 175.79.
79, so okay, 0.8 newtons. Old school, we put 1 dp. No one does anymore. Used to put that. So you know that, we need the angle. So what's the angle now? I'm going to go, I want that angle down there. So how quick, if it was sine rule, I could just go 80 over sine theta. There's 1 p. And this is 175.8. And I could go 175.8 on sine 155. Any people still prefer to do that?
Whoa, you just rounded it. No, you'd have to put that whole formula in for the sine 100. No, for the 170.
What is your brain doing to you?
Well, we're not allowed to round until we get the final answer. Otherwise it's
Exactly.
incorrect. So you'd have to put that formula in.
So if I made that back to what? Andrew first, I don't know if this is what you said to me. So we've
But
got
I
that
mean,
7.
maybe that's rounded. Is that
Yeah,
rounded?
that's
It is rounded.
Yeah, so you'd have to put the whole formula in.
Now, have a look. If I want this angle to the nearest degree, and I've got 2 decimal places there, and these are all stored exactly, or to 16 decimal places, I think on the calculator. If it's got double precision, 16 decimal places are stored away for it, or at least 8, depending on the calculator. I've got to check. No, class pad's on 16, I think. So that's 2 decimal place accuracy. 2 decimal place accuracy in the answer means 0 decimal place accuracy, and in the working, I mean. 2 in the working means possibly 0 decimal places in the answer. So if it said to the nearest degree, we're okay.
Right.
2 decimals there, or probably, when I say probably, it's better, I should check it, probably about 90% chance that will be accurate, the 1 decimal place. You been nagged about that?
No.
So can someone get me the angle? Who prefers sine rule to do it? Who prefers the cosine rule to do it?
Cosine.
Cosine rule. So then I would have gone, mate, I would have just gone 80 squared. Yeah? And I would have gone those two. 100 squared plus 175.8 squared, 2 by that. So you didn't have to think to do that, did you?
No,
I probably would have gone with 7.9, but you know. For the purpose of learning the question, I wouldn't have worried, and I would have gone the cos of theta. I probably would have written as x, and then I would have just gone solve. That.
oh, I just put the angle formula in my calculator.
Oh yeah, you got the other way probably.
Yeah.
Easy. So you would have written cos of that equals that plus that minus that. That plus that minus that over all of that. Yeah, done. What's the angle? You got it for me?
Yeah, 11.1 degrees.
11.1.
Oh, I suppose
Yeah, yeah. So let's go back to our diagram. 11.1 degrees. So what's the answer to the question? Right over here. Okay, the resultant has 175.8 newtons. Oh, that's terrible. Yeah? Where? What direction?
11.1 degrees from the origin.
Yeah, we're from at 11.1 degrees. How do you say?
On the initial starting point?
Yeah. So if I've got a point somewhere, where's 11 degrees? Is it there? Is it there? Is it there? Where is it? It's relative to 100 newtons.
Relative.
Yeah, so you could say it's 11.1 degrees, you want to be fussy, clockwise from 100 newtons. You could see, let's say 11.1 degrees from, would that make sense? From the 100 newtons. Could have been the other direction, couldn't it? So fortunately, when you're handwriting a answer on the test, you can just go and make it obvious.
Yeah, question 2, you can pick the left triangle or the right triangle, the magnitude will be the same,
Yep,
but which direction do you choose?
the angle will still be the same.
Will it be?
You can talk about relative to this one and get the angle. You can talk relative to that one and get the angle. You can say relative to the shorter one. You're right. You could specifically say relative to the 200 metre. 200
Yeah,
metre.
so we could get 2 different answers.
Yes, what looks like 2 different answers. Yes, you're right. You get 2 different answers, no from mark both. Have to look at it and see. What's X? Someone got extras?
Would you have to write both answers to get the question
No,
right? or-
just one. Remember, all it doesn't say, it says magnitude, that's obvious. It didn't say 2 directions. Remember, the 2 descriptions will describe the same direction. So don't get too bogged down, that we'll do some questions and we'll work through. Now, do we go through it? Someone get that for me? Cole, what was X?
369.7.
69, and then you two ask yourself, is that reasonable? It's reasonable. So now I can go, how quick do you do it? Can we do it your way? You'd go cos theta.
Yeah, equals b squared plus c squared.
So which one's a BC? Do you see it
so
without
I-
letters?
No, I just see it as it'll be 250 squared plus 200 squared, take 369.7 squared over to 250 times 200, and I'll give you the cosine value, and then this cosine -1 of that, and I'll give you your angle.
Fantastic, mate. I'm impressed. Elijah, you understand what he did?
Do you use the cosine rule?
Yes.
And yes, I do.
So instead of that, you could have just gone,
Guess you could have done some.
that's the important pair.
Yeah.
You have to have the unknown in the important pair. Then you'd go 200 squared equals those two. Minus 2 times those two. You understand me? Or the cos of theta. And you could just go solve. Now if you use theta, then you've got to tell it you use theta. But if you use x, defaults to x. So most people just go x and get the answer. Yeah?
Yeah.
So x can be used for an angle. Okay? Too easy?